Hi. Hello. Actually, those are in the attended the yesterday. I have day before yesterday. Actually. Hello, everyone. Is it visible? Yeah. On chat, I have to check once. So I have to say in that yesterday's example that I already shared with you. You know that the most important thing that I have explained that is in cross validation technique. So many people's in Friday session they never attended. Maybe near about 8 to 10 peoples they have attended, but in that session, we have discussed about a major thing related with the cross validation. Even we have seen a difference between the cross validation techniques of strategy, stratify cross validation, and another one k-fold cross validation. Okay, so today the first thing that before I'm going to explain. But Friday is always repeat. No, actually, Sunday is always repeat. Even we have discussed about that. You never missed it, but I have taken the example, repeat example of Sundays. So hope so you got that one. So the repeating things that can solve the many problems. So I think if you guys attended that session, then that's else you can see that video as well. It will be helpful to you to check the difference. Okay, so why to use cross validation techniques and all like this. But today you are going to learn about performance matrix, and today is the most important part about performance matrix is in cross confusion matrix. Okay, so this will helpful to you to check a performance of your algorithm. So many times we have executed, we have calculated accuracy score of our algorithm. But today we are going to work on the how this process is executed and how this whole work is going on, right? And so I think you will you are going to see this one, not an issue. Saturday and Sunday is a main class. This is what team told us. Yeah, don't worry, that is the main thing. I never taken any new things in Friday, but revision also taken, no? So revision, it will be helpful to you. Don't worry. Rahul. Friday I will not be able to attend. No, don't worry about it. Go through the video. It will be helpful to you. Why I said the Friday session? Because revision I have taken cross validation technique Sundays revision. So the revision when happens, it will more clarification is coming on the always into the revision. So go through that video. Hope so. So today we are going to work on the performance matrix. I will share the PPT here. Okay. So this is in Sunday session, and this will helpful to you. This session is most important. Now you're attending this session. This will be helpful to you to understand about whole journey. I'm sharing the screen once again about PPT. There was in class of yesterday. No, yesterday we haven't taken in class. We have shared the assignment and some problem statement, analysis problem statement, and one assignment on cross validation technique. Yeah. Yes, thank you. See, guys, in front of you, that is a performance matrix, right? So why to use performance matrix is for the checking. Wait, sir. Actually, I messaged to the group. Maybe I have to ask again to the team. Wait. Hey, I'm fine, guys. It's really happy to see once again in this session. I used to with this session now. Before 2 days, I'm ready for to give the session. This is kind of interaction now I had with you. So see, guys, the performance matrix we have to use for the checking how the output is coming, means what is the checking the truth behind the output. So many times the people thinking about uh, calculating the accuracy score isn't finalized or what, calculating the means final output like a 70% output, 30% is your wrong. So this kind of structure is happening, or why this is happening. So in my opinion, what I'm thinking, performance is secondary thing, right? Performance is secondary thing. So what is the question, Francis? There was many topics that there is in syllabus but not yet covered, but classes are getting over in 15 minutes. Can you please let us know topic will be taken up my yeah, that is the topic still. Yeah, to check, we have to take, don't worry about it. If suppose this kind of problem is coming, no, team will inform me before that, and definitely I will inform you if suppose that is there any means closing or something or, so don't worry about it, sir. This performance matrix, and after that we are going to see the any algorithms, remaining algorithms. So this is the major part of machine learning, and then we'll go for the ANN, so artificial neural network. This will take only 2 sessions, means 1 week total. So it will be helpful to you. Yes, Francis. So now I'm going to explain you about performance matrix. See, in the performance matrix, there we have so many terms like that, like a confusion matrix, right? Accuracy score, precision, recall, specificity, F1 score, and in that there we have the type 1 error and type 2 error. So even this kind of questions definitely will get into the interview. In machine learning data analysis interview sessions, you will get a question about what is a confusion matrix, and even you will get a question on the basis of type 1 error and type 2 error. So this journey is definitely helpful to you to understand all the process. Okay, so let's go and check out and explore the whole things. Is it visible, and shall I move forward? Yes. So I think chat is open, you can check it now. Okay, so see, so what is a confusion matrix? See, What is a confusion matrix? Confusion matrix has in terms, it's kind of confusion. That's why they have given the name of confusion matrix. So I will tell you. And today's session is a little bit headache because many of the terms that you will get here. Okay. So in the confusion matrix, there we have the true positive, true negative, false positive, and false negative. These are the four terms are there. Check out the diagram in the right side. There we have the red zone and green zone. Okay, the green zone that shows you the example of always we have to say that my algorithm has given a 90% accuracy and 10% is my negative, means negativity is there, right? So that 90% is divided into that green part, means true positive, this one, see, true positive and true negative. Confusion matrix is a summary. What I'm telling you, it's kind of summary of your output, right? So whenever I plot the confusion matrix, definitely you will see some terms here: true positive, true negative, false positive, false negative. Okay, so these are the terms. Why need be confusion matrix, precision and recall, F1 score, confusion matrix with the scikit-learn, means we are going to implement on the algorithm, and then multi-class classification. Today we are not going to work on the multi-classification. Why? Because this is huge. Even you will get a problem to understand confusion matrix because there is a 2 by 2's matrix. But when we go for the multi-classification, there isn't more than 2. It's kind of 3 by 3, 4 by 4. So you guys are thinking about how it is possible with the only 2 by 2. See, 2 by 2 is nothing but probabilistic answer. If suppose if you have a true positive, credit card fraud detection or heart disease problem, there isn't 0 and 1 and yes or no kind of structures are there. So whenever I'm going to use a confusion matrix with the two categories, means two output values, so that time you can use 2 by 2's matrices like a true positive, true negative, false positive, and false negative. So hope so. You will get so many things now about the performance matrix. Let's move on the next slide, and it will be like a definition completely. So confusion matrix is a summary of prediction result on the classification problem. Obviously, whenever you have a classification problem with the 2 by 2, not only for the 2 by 2, you will get a multi-classification as well. But whenever there is a classification there, if suppose you used a confusion matrix, then it will be helpful to you to understand and to do a whole scenario, to check on whole scenario, you can use confusion matrix. Even check out the confusion matrix is a matrix used to determine performance of classification model for given set of test data. Obviously, no, given set of test data means how to calculate the prediction. Yes, is it correct that that we are using ypred is equals to L1? L1 is your model dot predict into the bracket x test you are passing. Is it correct? Yes or no? Yes or no? Let me know what I'm telling to you. Whenever you go for the prediction, ypred is equals to model dot predict into the bracket x test you are passing, and whatever the x test you are, means x test is nothing but your testing observations, and you are passing into the model and finding the predictions, finding the output values. That is ypred. So this is different from the logistics or under that part. No, see, we have covered. This is not an algorithm. If suppose if I'm telling you algorithm, then definitely I will tell you this is algorithm. This is a performance matrix to check a performance of your model. We have seen accuracy score, but we haven't seen the logic behind that, the working behind that, right? And accuracy score and this confusion matrix is in kind of summary. Why this means how much we can believe on that algorithm, means how much we can believe on the output of that particular algorithm. That is going on here, confusion matrix, right? So don't worry about it. This is a end part of any algorithm. Is it correct? This is end part of any algorithm. Means after the prediction, when you are taking that x value and passing into the accuracy score, Is it correct? No, you are passing into the accuracy score and taking and checking the accuracy of your model. This is nothing but your performance matrix. Are you getting my point, everyone? So you guys are thinking about why there we have taken KNN, and even we have seen logistic regression. So why we are now going to towards the confusion matrix? See, first I explained you the life cycle of any algorithm with the KNN as well as the logistic regression. Right? In the KNN, you can use the multi-classification problem into the k nearest neighbor. In the logistics, you can use the binary classification problem statement into the logistics, not an issue. After that, I can go for random forest, naive bias, decision tree, SVM. These are the four algorithms are remaining. But what I'm thinking, before going to complete this structure, why not I tell you the performance matrix, and afterwards we can go for the other algorithms. And once you learn this confusion matrix, means performance matrix, then definitely this is kind of end, means it's kind of machine learning journey is going to end in very soon. So definitely you can, I'm not giving you any wrong direction, so that don't worry about it. Yeah, and stratify, I think go through the Friday session once. I have compared with the Stratify, Rahul. Once go for that Friday session. And after this confusion matrix scenario, I will give you a quick recap about the Friday's session. So it will be helpful to you all, right? See, here we have the what is the confusion matrix. In the performance matrix, there is an confusion matrix and accuracy score. There is an two types, confusion matrix and accuracy score. So whenever I'm going to use 2 by 2s, means two categories like a binary classification output, then you have to use a 2 by 2s this confusion matrix concept, right? See the dimensions, there we have the two dimensional concept. And you know what, one interesting fact that we have here, that is see, check the confusion matrix diagram. There we have the true positive TP, false positive FP, true negative TN, false negative FN. So this is check out the terms positive, negative, positive and negative. So definitely, if you have a notebook in right side, if suppose you have a notebook in front of you, just write down, draw this diagram. Which diagram, you can draw this diagram. It's okay. Means only this square bracket and draw this one. It will be helpful to you. I will tell you each and everything. Is TP is equals to TN? Yes, it's kind of accuracy. In words, no. True positive, true negative. Okay, draw it your diagram. If once you complete your drawing on the notebook, just tell me yes, because I will tell you what's the tricks. What are the tricks that you can do to understand and memorize this one? Because so many confusion will come here while I'm explaining to you. Okay, I think hope you have done the drawing here. Write down the TP FP, means the names. TP is nothing but true positive, FP is nothing but false positive, and FN is nothing but false negative, TN is nothing but true negative. So let's we can go for explanation of every terms that we have into the diagram. Means TP, TN, like that. Okay. So just understand the one concept, that is you know just think about it. Your output, your accuracy score is coming 90%. Just understand the one term, 90% means what is the 10% is your negative, no? Is it correct? Yes or no? 10% is your negative. right? So now that 90% is divided into the TP and TN, means green sign. Yes, this is a truth table. Those are in the field of statistical analysis, no stats and all. You will get to know about this easily, right? So 90% accuracy is divided into this TP and TM, and that 10% accuracy is divided into the red zone of FP and FN. Okay, so you have to do one thing here. Just write down their accuracy score of 90 and 10. Okay, out of 100 you are getting a 90% of accuracy, and that write down the small amount of line into that TP 90 90, TP 90, TN 90, FP 10, FN 10. Now I think hope you have done the right two table of any gates. No, it's this is a little bit different. I will tell you that truth table is different, but it's kind of truth table. Okay, now guys, one thing that we have to understand, TP and TM. Okay, so TP is term. Now I'm going to explain you TP. Yeah, 90 TP and 10%, 90 TP and 90 TN. Just see, Rahul, 90 TP and 90 TN, because this green sign is giving you 90% accuracy, and false means red zone is giving you 10% of accuracy. You can just write it down there, 90 and 10 like this. FP and FN is in 10. Now let's go for the explanation of this one. Okay, explanation of this one. Now just imagine this cancer patient is there. Okay, cancer patient one, when person is having cancer, that is an one, means one is nothing but having cancer, and zero is nothing but the person is not having cancer. Just write down the side by side note. One is nothing but having cancer, zero is nothing but not having cancer, like that short note you just write it down there. Okay, now the point is truth positive, means true positive. So what is the TP? See, I'm discussing about this line, this TP, true positive. True positive are cases when actual class of the data point was 1 and prediction also a 1. See, means your observation values output is there, no, actual output is there. In the data of cancer patients, there isn't some outputs are there, no, actual value we can say that, right? That output value is saying he has an cancer, and you are when you are going to predict, your output, predicted output is coming, yes, that is that person is having cancer. Just see the terms, the case where the person actually having a cancer and model classifying he his case as a one, means yes, true, means your actual value is true and prediction value also a true. Are you getting what is a true positive? I will tell you what is the whole structure. TP is nothing but the person having cancer and model is giving yes, that person is having cancer. The one term is covered. Now we are going to work on the true negative. That is completely opposite to the downside. See, TP and TN, green sign. Once again, TN is here. Now we are going to discuss about TN. So what is a TN? Your actual value is saying that person is does not having any cancer. See what I'm saying? The true negative is means your actual value is saying that person is does not having any kind of cancer, and your model is also saying that yes, he don't have any kind of cancer. Means this true negative is nothing but does not having cancer. Your model is also said that does not having cancer, and your actual value is there present, no, that is also a does not having cancer. Is it correct? Got the point? Two terms. TP is nothing but, what is the meaning of TP? TP said if you have a cancer, then model also predict cancer. If you don't have a cancer, true negative is nothing but if you don't have a cancer, your model is also going to predict you don't have a cancer. Now got the point, Rohan, Rahul? Means both are, TN is nothing but model is saying he don't have a cancer, and actual value also is like that he don't have a cancer. When actual value is equals to model value is equals to 1, that is in TP. Yes, Danny sir, that's correct. So shall we move forward? Yes sir, that's correct. Now model is 0. Both are with the actual data same and right. Yes, yes, yes. Means the way of the actual output is there, no similar kind of prediction value as well. Means model accuracy, model predictions also same. I think the two terms you got, yes or no? Yes. So now just think about it. TP and TN is nothing but your accuracy score. Means the way you have write it down, no 90%. That 90% lies between this TP and TN. Why? Because this is means lying between that, because whatever the output is generated no into the X test on the basis of X test, that is matching towards the TP and TN. If suppose your actual value is saying that person is having cancer, your model is also said yes, that is and cancer. And TN is nothing, model is saying that does not have any cancer, yes, model is saying does not have any cancer. Means these two terms TP and TN are directly affected on the output of accuracy, means 90%. Now got the point? 90% is over. 90%, why that 90% is coming? Now you got the point. Yes. Now false positive. Now the false positive isn't just that line, means that false positive and false negative, that red zone. So what is the meaning of that? 10% data is divided into the FP and FN. Is it correct? If suppose 10% data means, if suppose thousands of predictions you have calculated and 90% of accuracy coming there, means your 900 values are correctly predicted and your 100 of values are not correctly predicted, because there is an ambiguity, there is a problem in between the accuracy, means in the algorithm means your model is not learned properly, right? You got the point? Yes. Are you getting my point, everyone? Now see the false positive. False positive says your actual value is in 0 and prediction you are giving 1. Your actual value is in 0 means 0. What is the meaning of 0? When a person is not having cancer, but model is predicting what? But model is predicting true. Yes. So just imagine that person is does not having cancer and model is predicting that person is having cancer. The similar kind of that. Now you can tell me what is a FN now. Model is, your actual value is saying yes, that person is having cancer, and model is saying does not having cancer. Now FP you got, FN you got. Yes, yes or no? Write it down there. You know, write down there is in blocks you have drawn no into the notebook. Write down in the block of TP, TT, true, true. Opposite to that, false, false means FF. TN, the position of TN, you have to write down there FF means false, false means actual isn't false, prediction also false. TP is nothing but true, true. Actual also true, prediction also true. F is there. F F is there. F is nothing but what? F is there. You can tell me now. You can tell me now. FP and FN, please repeat not under. FP is there. False, true. False, true. Write down the FP's block. False, true. And there is a false negative. FN's position. And write down there true, false. TF. Means it's kind of short notes to understand, right? Whenever you go for the interview, just see that diagram and go for the interview. So it's kind of structure that I have shown you in front of you, right? I think now got the point, right? Yes, this is the terms that we have seen here. Let me know the whole terms that I have. I just explained you got the point or not? Means TP, FP, FN, TN, right? Now the confusion matrix part is here. Means calculating these terms is over now. Means he will show you the output, not an issue. After the confusion matrix, this using of same confusion matrix terms, how can we calculate the accuracy score? Write down the accuracy score in your notebook and just see the terms. Accuracy is classifying problem and number of correct predictions made by the model overall. It's all, sorry, I have all kinds of prediction values. So what is the meaning of this? So accuracy is prediction. Already I said no. Accuracy score is nothing but this middle part, means 90% of accuracy you are getting, that TP and TN. What is the TP? True, true. What is the TN? False, false. Means you are actually what you are expecting, what your actual values are there. The same output is given by the model. Is it correct, guys? So check out the definition. Check out the formula of accuracy score. There is an TP and TN divided by all the possible values. TP plus FP plus FN plus TN. This is nothing but your accuracy score. The way we have calculated the accuracy score, the similar kind of funda that in front of you. So when to use this accuracy? If suppose your data is balanced, then you can believe on your output. Is it correct? Is that correct what I'm saying to you? If suppose imbalancing problem that you have in your model, then how can you believe on that? Chat is open. You guys are there. Let me know. Is that logic for the accuracy for the given predictions? Yes, yes, yes. Yes, Dennis, sir. How to divide values in TP and TN? TP and TN. Actually, that's the terms. That's the thing that division comes under the false, false, and true, true. No, Rohan. Not in 50-50. On the basis of your output that is divided. No. So whenever I show the output, you will get to know that how many true values are there and that given by the model, how many false value that given by the that tn means false false true true, like that. But if we have null values, we feel it will be the random data. Will that not affect original prediction? See, creating and solving the null value problems, that is a pre-processing part, and that is, it's kind of, definitely if you are adding any kind of uh, means it's kind of you don't you don't have a value means that is a null value, and you are passing a random any that calculating the mean median mode, and you are passing into that, or any random value you are passing into that. But accuracy score is based on the any value you can pass. I can calculate the only accuracy, I can calculate the any confusion matrix problem solution, right? But what is the meaning of that? See, you don't, before you going to accuracy score or prediction values or prediction any model also, I want to tell you, you can solve first this pre-processing part. You can make an balanced, because random over and undersample random adds delete the data, so accuracy is not 100%. There is an I can do. See, the accuracy is part is an only giving a accuracy. Believing on the accuracy is an secondary part. The previously already said that secondary thing, accuracy score is a secondary thing, because you are going to balance the data somewhat. I think very rarely you will get and balance the data. Rahul, is it correct? No. How can you tell me that? Means suppose there is an 99.9% you will get an imbalance problem. So you have to deal with the, you have to always deal with this random oversampler and under sampler. Mostly you should go with the random oversampling and smooth. Do not go to try to go for the undersampling. Undersampling is enough to use for a small data set, but random sample is kind of you can means big data set as well as small also you can use it for the big data sets. Hope you got this point. Accuracy score, whenever you want to use accuracy score, that is an ethically true that you have to use balanced data. If suppose you are using imbalanced data, then how can you believe on your accuracy? Why? Because the check out the accuracy score formula, that is an TP plus TN divided by TP, means all these scenarios, all these terms. TP plus TN is nothing but that truth, means your the way you are expecting the output, similar kind of model is giving to you. So you have to believe on that, right? So hope so. I think hope you this got this point now. Now the term precision, the term precision, because of we counter white test and white rain, that's still not balancing. Obviously white test and white rains are two different things. No, 80% your data is into the white rain, and white test is having 20% suppose, and still not balancing means, I think imbalanced data you balanced and passing into the model, that time you will get a definitely imbalancing, so that the dealing purpose you are going to use that cross validation techniques, right? Will balancing, will garbage will get into the y factor, and that may affects on fn and fp. uh Model is based on whatever the observations are there. It's that you know that there I have added a garbage data, means random data you have added, that you only know. If suppose whatever the output is coming, whatever the scenario comes out means at the end, that time you only know that there I have added a 10% of extra data. If suppose the positive data means trusted data, if you are passed, if you are passing, then you can believe on your model. If suppose you don't know that I'm passing only random data, then there is a problem to trust. While balancing, yeah, balancing, sir, there is an many of the suppose small type of problem is there. No? So balancing you can do yourself as well, not an issue to, without using this imbalancing problem. You can add that some data into that and solve that problem. If suppose 990 data is and 10 data is problem is there. So getting a balancing, you can add your data or take some random data and pass it down. But trusting on your data, that is your work, means my work, that, right? Balance is equals to adding a garbage value. Sir, garbage value, not saying like that. See, if suppose if you are adding a actual sum of the data, extra data that manages your balance, it's not a garbage. Sometimes garbaging is nothing but huge amount of data you are increasing into your why to balancing. So sometimes you can say that that is an garbage to I'm adding. Why? Because in thousands of, it's kind of 5 to 10 thousands of data you are adding randomly, right? I think it will be good to use a smooth technique that will be helpful to you, Dennis sir. Try to use smooth so that the accuracy affected or not. Means as comparatively smooth and random oversampler. Random oversampler is chances to make a duplication of data. Dennis sir, is it correct what I'm saying? And smooth is trying to avoid the duplication of data and passing into the some natural data with the calculation. If the added value tends to actual value lesser the Fn and Fp. Uh, that's the major thing to reduce Fn and Fp, means increasing the output and reducing the problems. Increase we suppose you are getting the 90% and 10%, you are trying to increase the output to 90, 95 till now. So you have to reduce the how much lesser, the way you said, no, how much lesser the output, how much lesser the Fp and Fn, means that 10% you are decreasing that one. So that much your output, that much you can believe on your prediction, right? See, sorry for interruption of this one. Precision. So, precision is in terms that comes under the interview sessions as well. Actually, precision is a measure that tells us what proportion of patient that we diagnose as a having cancer actually had a cancer. See what I'm saying. What is the term about precision? The measure that tells us what proportion of patient that we diagnosed as a having cancer, means having cancer means that is a having actually cancer and actually had a cancer. The prediction, the predicted positive, and the people actually having a cancer, that's correct, no? So people having cancer. So just what is the meaning of FP? What is the meaning of FP? Anyone knows about FP? FP is a false positive, means false positive. What is the term that tells you that false positive? What is the terms? Means actually he has a cancer, but your model is saying does don't have a cancer. I have to show you that FP. Zero is nothing but actually that model is does not having cancer, and your prediction value is coming, he don't have an cancer, he has an cancer, like that, means positive he is giving. It's kind of false true, right? False true. Now if I'm going with the precision, what is the TP divided by TP plus FP? TP is and true positive divided by TP plus FP. How you know how to store these terms in your mind? Just FP, just write down. Just FP is nothing but false, means your model is saying false, but sorry, your actual data is saying false, and your model is saying true, means positive. And Fn is nothing but, what is the meaning of Fn? Your model is saying he has an cancer, and n is nothing but your model is saying he don't have an cancer. Means your actual value is saying he has an cancer, and model is saying he don't have an cancer. Now got it up. Now the TP and FP. TP and FP. So this FP part, when it comes, wait, I will show you this one, FP. So this is nothing but precision. Write down that block, right? Draw the diagram. That same on that same diagram, just write down the make an arrow and pass it down there. That is precision. FP is nothing but your precision. FP is nothing but your precision. TP divided by TP plus FP. This is your precision. And precision only you have to call, that is an type 1 error. Write down the downside of that precision. This is an type 1 error. Are you getting the point of precision? The precision is saying TP divided by TP plus FP. So you know that TP, what is the, we got the formula. So what actually the I'm telling you, check the formula, not an issue. See that easy to understand the formula, but behind the logic, just write down there precision. FP block is nothing but your precision. Precision is nothing but your uh, type 1 error. But what exactly it mean to us? Actually, precision tells you, precision tells you how many patients are there. Okay, how many patients are there? So this is telling you that how many patients are having the cancers, and that actually had, means what is the meaning of this one? What is the exactly term of FP? Actual value is saying does not have any cancer, and prediction is saying yeah, that person is having cancer. It's kind of, it's kind of like this one. Wait, I'll show you in the chat. It's kind of like this one. A is equals to 0 and model is saying 1. The terms like this one, right? FP. Then TP is also said same thing. No, TP said true true. Model is having false. Model is having true, and actual values are true. Accuracy is different, sir. Accuracy score, it's kind of, accuracy score, it's kind of, you are finding the true positional values. In the precision, you are not finding the positional values. You are working on the errors in the precision. Accuracy score is in positive thinking, means positive ways he goes through the output, means the TP and TN is your accuracy score. And precision is an kind of, you are working on the errors. If you want to go for the calculating and reducing the error, you have to go through the precision, and that's why we can call the type 1 error. Recall, see, this is, recall is a one of the kind of error, type 2 error. See, this is a type 2 error, right? And check out the way we have taken the precision previously. TP plus FP, this is a precision, and TP plus FN, this is nothing but recall. And recalls a second name is in sensitivity. Recalls second name as in sensitivity. And this is the another name, type 2 error. Recall sensitivity is it visible? I think I just messaged you. Are we measuring or classifying error quantity? Both thing we are doing, sir. Even we are measuring as well as the classifying the errors. In the accuracy score you have measured, that is a 90% and 10%. But in the in the confusion matrix you are classifying, means what are the errors? Errors are there. FP and FN are errors. FP and FN are errors. But in that errors, what kind of error we have? FN type of error or FP type of error? We got a 90% accuracy, but in that 90%, how many truth are comes truth? How many false are coming false? Now got the point? Actually, this is little bit tricky words are there. That's why getting problem. But hope so you are getting this one. See, now the way I said no, the precision and recall. You know what? Precision comes into the type 1 error. You know, when interview comes, no, the interview they will ask you what is the type 1 error. You have to tell them that isn't precision. What kind of precision gives you? Precision gives you the first, means whenever we get an output, whenever we calculate the accuracy score, there is an, you have to give the any example with that. There is an accuracy like the 90%. So 10% is your error, and that 10% is divided into the precision and recall. So the first part of that, the first part of error, that is in precision, that is the only we can call type 1 error. And then you can tell them like a formula like a TP divided by TP divided by TP plus FP. If you tell them about this one, then definitely it's workful, right? If you comes to the recall, there is an recall type 2 error. Recalls also TP divided by TP plus FN. And you know, the most of the people they get confused about FP and FN. Definitely, they are definitely get confused about this. Why? Because FP is nothing but P. Whenever you get a P, P is nothing but true. P is nothing but that isn't true. Means you have to completely, whenever you want to go for the definition of FP, just understand that P is nothing but true. And what is the definition? Your model is saying 0, and your actual value is saying 0 and model is saying 1. Means that person does not having cancer, but model is saying yes, he has an cancer. This is nothing but FP. And what is a FN? FN, N is there, no? N is nothing but false. N is nothing but false. Means your actual value is saying that person is having cancer. And means FN is saying now false, means does not having cancer. So that is an errors. Errors are completely opposite to the actual values. Means FP and FNR both are opposite to the actual values. And remember the kind of that ways only. Do not go in the terms of TP and TN. These are the different things. 90% of accuracy, truth, data. Now got the point, guys? Yes. See, recall gives us information about classifiers performance with the respect of false negative. That is correct, no? Is it? What I'm telling to you? Why? What is a recall? What is a precision? Recall gives us information about classifiers performance. Classifiers performance means your accuracy, means your model predictions. And what is a precision? Gives us an input information about its performance with respect to false positive, false negative, and false positive. How many did we caught? How many did we miss? Don't worry, don't worry. Actually, we have to cover up these terms. No, that's why I'm just taking this one. I will take you with the example of this one. Yes, after this one. After this one, yeah, because we are going to implement the logistic regression. Actually, after so many times we are taking here theory. That's why. So don't worry. I think hope you this. Everyone, please tell me. Have you got the point of these terms? How many terms that we got? Try fn factor called as a recall, because recall is nothing but you are going to reduce that recall problem. Means recall means you have to work on that once again. Means how many did we miss? If suppose I will implement, sir, Danny sir, we will implement this one and I will tell you whole process. Okay, so let's go for the implementation of confusion matrix, and you will get to know that recall and all. So side by side, first, once again, we are going to implement the logistic regression. So quickly, you can tell me about some codes so that I can check pandas as a PD, import numpy as a NP, data set is equals to, I will take on hard disease. Yes, we got the point. Okay, now see, the problem is that, can you explain when to use? Yes, yes, I'm doing just, that's why I'm just doing the whole work here. So data set, one and zero. Oh, sorry, actually I have to use here. At the end of you have to use, but this is imbalanced. So I already told you that you have to do an imbalance problem solution. So can you tell me what I have to use here? So screen is not changed. I have done this much code. Sorry for this one. Can't see your Python skill. Okay, sir. See now, I think it's visible. So what is the code for the trend test split? Wait, we are not going to go for trend test split. We are going to work on imbalancing problem. What is the library for the imbalancing? Can you tell me? Can you pass the code as well? Not an issue. IMB, is it correct? This is correct or not? What I have to pass here, resample for all data set, the X and Y is going to take on the same code. Yes, yes, you can, no problem. It's not necessarily X and Y, you can take any variable, but you can go with it. Fit. Oh, sorry. RS dot fit. This is, I think, right? Sometimes I forget the code little. Okay, so X data and Y data is coming. So with that, I'm just using here X underscore data and side by side print underscore Y data. So this is data we got it here. With I'll take one more thing. Yesterday's file also there. So side by side, I can use this one code. Okay. Oh guys, I'm just doing the random code here. See, this is yesterday's file. Okay. I have, if you guys see this file, then you will get to know the whole just journey of this. Don't worry about it. See now, this code is that I have shown you in front of the screen. So this is nothing but zeros count into Y data is in 165, one's data is in 165 into the Y data. Okay. And the way we have seen this X data and Y data, we have sliced down the X and Y. Okay, not an issue. Let's go for now. We have an balanced data set. What I'm saying, we have a now balanced data set and I'm passing into the where into the code. So what I have to use, can we use the X train, Y train, X test, Y test? That is a normal behavior that previously we have seen, right? From sklearn, what I have to pass dot model selection import train underscore test underscore split. Okay, and x train comma x test comma y train comma y test equals to train underscore test underscore split into the bracket x comma sorry x underscore data comma y underscore data, because we have calculated with the we have applied imbalancing problem x random oversample, so that I'm passing that x data y data. And what is this test size is equals to what I have to pass here. Test size equals to suppose 0.2. I'll pass 20%. Now you'll get to know about that whole journey. 165 divided by, just to calculate the 20%, how much it is. Okay, now see, the Y-pred is there, no? So this is your output. What I'm saying, this is your output. And now I'm going to use confusion matrix from sklearn dot matrix. See the library that I'm passing matrix import confusion matrix. Maybe this is correct. Yeah. See sklearn dot matrix import confusion matrix, and you can add like this one also, accuracy score. And first you can pass here what accuracy score you want, no? So AC is equals to accuracy score into that bracket. What I have to pass here, what I have to pass, y read comma y test. So just check out y read comma y test. These are the positive things, no? You are comparing your actual data with the predicted data. Is it correct or not? Yes or no? Tell me. See here, you are getting the 89% of accuracy, right? 89%. So what is the 89% of accuracy? If you discuss about in if suppose if you discuss on the confusion matrix, no, there is a I already told you, no, the true positive and true negative values. So that comes under that scenario in the cross section green sign of that. So side by side, I'm just passing you confusion matrix CM CM is equals to, I'll pass a confusion matrix here and passing into the bracket y, sorry, how much is accuracy without confusion matrix? Means both are same. They have calculated the both are same. So I will show you one thing here. See how much the data size here, data set dot shape, data set dot shape. What are the total values? 165, 165. How much it is? 240, 230. Is it correct? 270 maybe. 3 330, right? 330, right? And 330. What is the 20% of 330? What is the y test shape? 66. 20% means 330s, 20% means 66. So make a total of these values. Can you make the total of what is the 29 plus 1, that is an 30, 30 plus 30 is an 60, 60 plus 6 is an 66. So what is the output? Means what is the y count? 66. What is the test cases count? 66. Means you are asking to the model 66 questions and he is giving us a 66 answers. That's why your confusion matrix containing the 66 values. So 29 plus 30, this is nothing but your actual values, and predictions also are same as the actual values. True, true, false, false. That's why this is an 59 outputs are correct, and 1 and 6 is nothing but, this is nothing but your false positive, and this is nothing but false negative. Means 6 and 6 plus 1, this is nothing but your negativity. Means the accuracy is an 89%, no? So that 11% is nothing but your 6 plus 1 means 7. Now what the point? I think, are you getting the points? I know, that's why they have given the name of confusion matrix name. So do not worry about it. Can we do the sampling? Can we send 100% to the model and see what the matrix show? Yeah, you can share. If suppose if you, that's a good question. Actually, you can pass here xtrain. Is it possible? No, xtrain you can pass it there. Danny sir. Or you can, you are saying that x data you want to pass full x data, means x data like this one. full X data. Yeah, we have sliced down that X data, so that is an completely. And check out one thing here, that we have passed 100% data, not an issue. Wait, I have never added here. I will show you first data shape. How much? 330 means you are going to ask 330 questions to the model. Okay. And comparison purpose, you have to pass here wide data. I think you got the point. See, your model is giving us a 84% of accuracy, and this is an confusion matrix. Means make a total of these four values. 130 plus 149, that is nothing but almost 260 and 270, 279. Truly correct, right? Yes, it should be 100% or close to it. No, this is 100% completely. Means accuracy is, and you are getting 84%, but you are passing 100% data. Make a sum of this. 35 plus 16. This is an 41 and 10, 51. So make a sum of 271 plus 51. So this is nothing but almost, how much it is? 80 and 20, 330. This is correct, no? So this is saying whole data is not correct, the actual one. Who say no? Model learns 100% of data, and we are asking to the model 100% of data. Means he learns 100. Sorry, wait. He learns 100% or not? He learns 80% of data, and you are asking 100% of question. Now, what the point? He learns 80% of data, and you are asking 100% of questions. That's why we are getting this one. Upper values for correct. Upper values for correct means, yes, this one. These are the incorrect. So please send 100% of data. Okay, we are passing here X data. Now the process is changed. 85%. Before we got an 84%. Now we got an 85%. And check out 150 plus 133 is nothing but how much? 283, no? 283 truly means it's correct that we have passed here. And 15, 15, 30, 30, 40, 45, 47. This is 47. Yes, still not even 90%. Yes, sir. That's why no, that's the thing that we have to do. That's the thing. Over the 100%. You cannot expect that I have trained 100% and he should give the 100% of accuracy. You cannot. Machine learning not works like this. We will try to improve. We will try to improve, work on the data set, work on the suppose cross validation techniques also impact on that. So we will work on that cross validation, because model, while learning the model, he should may learns imbalancedly. That's why may affects on this one. Is it only TPT? Which one? That 283, no? 283 is that one. Truly correct. Truly correct. Those value. Yes. See this one. 133 and 150. This is nothing but your TP and TN. And this is your false positive and false negative. Now what the point? You know what, actually you should go for the trying to implement this examples on previous algorithms that you have explained, means you have learned, right? uh, Dense, I think 80-20, 80-20. I'm not getting service now. Are you getting this 80-0 and 0-20? It's kind of structure. Ideal case result. You can think like this one. Yes. Actually, 85% of data. See, the point is that how can you believe on your model? See, it's not, it's not meaning of always you have to train all the data. You have to ask some basics, like you have to pass some 80%, 90% of data and make a 10% of data to ask that your model is correct or not, like this. How to stimulate means, stimulate means, see, affecting the 32 values are affected, no? Means 15 is okay, not an issue. That is a type 1 error, and type 2 error is in 32. 32 is nothing but your false negative, maybe, right? False negative is nothing but your model is saying true, and sorry, your actual data is saying true and model is saying false. Model is saying that he does not have any cancer, like that. So we have to check that values. That means it's not in that values, you have to check the model as well. Means go for the once again pre-processing, go for the once again, if suppose you have to try for the cross validation technique, it's kind of model tuning. Why, what I'm saying model tuning, you have to affect, you have to check for this one again. If suppose
So
uh,
I have one question. What I'm trying to ask is,
hmm,
can we get a sample, say that this is 100%, we give the data and we get a 100% confusion matrix. Once, then we will reduce the test size to from 100 to 20 percentage, sorry, 10 percentage, so that the lesser, so that the accuracy goes down to 85, 70, like that. First of all, we need to have a ideal value like 100% accuracy. Then we will see how increasing the test size or decreasing the test size and random state equal to 0. Then we will find that a straight line of accuracy fall will be happening by changing the values of test size as well as the random size over the 100% value, which means we will get a curve of accuracy, like starting from 0 to 0. It will be on the top portion, it will be 100%, then it will be dropping the accuracy to, say, as we see, 83% maximum. Then it will go up because of we are increasing the test size.
yes.
So can you stimulate the same U parabola of the stimulation of accuracy from ideal case to 0 state? That is, the moment which we give the ideal state, the maximum prediction will be 100% or equal to 100%, and the last value will be the least accuracy.
Last value.
Then it will come up. The parabola will come up to the balance back to the ideal case, or it will be a straight line, or it will be a straight parabola. Either case, it will be there. There will be a accuracy formation will be there. Either it will be a straight line, that is from 0 to 0 to 100%, or it will be a parabola.
Yes.
So
Yeah,
can you stimulate that a value? Like I am thinking in which way combination I can get the 100% of accuracy or near to the 100%, or which combination gives you 0% of accuracy, which is also acceptable.
I got your point. Actually, the range of that accuracy, means where that model is lies with that. Always we think about that. What kind of where we have to go and stop there, right? That main scenario is there. Actually, if suppose if you try to change with the test size, if you try to change with the random state, your accuracy will changes always, and you have to calculate near about 5 to 6 accuracy scores and apply the same portion of testing case. Okay, apply on the same model and same test case is there, and check out the whole process. If suppose model accuracy, the way we have seen in the cross validation technique, applied on the cross validation technique, then what will happen, there is an 6 to 7 accuracy scores are there, and in that every time some will goes up, some will comes down, some will goes up, some will goes down. So the model is going to make a bridge between the somewhere, means it's kind of the balancing of your accuracy scores. This the somewhat somewhere that model is going to balance with the accuracy score as well. If suppose if you are changing your test cases, means if suppose you are increasing the 2.2, 2.3, 2.3 of test cases, test size, and your model is going to give the 78 to 79, 78, 30, means you have to check, you have to do a R&D of them when my model is going to give the accuracy scores while changing the test size and random state, and what kind of proportion I have to set the random state so that my model is going to increase the accuracy scores as well.
Can you
Right?
have
It's
do you have any diagram of a accuracy graph? That is, in which one, if I increase the test size and the random state equal to 0, this will be the graph position. And if I increase the test size, decrease the test size and increase the random state, it will be this size. Like that,
yeah.
there will be a swarm. Can you show on image and explain this
Diagram
thing, the accuracy graph of
accuracy.
because it
It's
will be,
it's
there
kind
will
of
be a
model tuning, sir.
break-even point for everything.
Sorry, sir.
There will be a break-even point for everything. That is, the test size will reach the optimize, and this random size will reach the optimize.
Diagrammatically, if suppose if suppose I have
Rabe,
many.
why don't you pass this entire model through a for loop and just increase the test size value? We can see the outcome of it.
Means you're thinking that I have to change the test size, means show the different outputs, different accuracy scores. Yes, actually, that is nothing but model tuning. You can do. If I pass into the for loop, wait. It will be helpful to that. I have added here X data and Y data, means it's whole journey, whole data. This will be helpful into the cross validation, right? If suppose we pass there. Wait, is it possible with the cross validation? We can check. Graphical representation is more clear. Actually, graphical representation means I have to create that like some design so that I understanding purpose. This is an which data it is? Hard disease. Wait. I think the Fridays data. I'm just taking this one. These are the libraries that I have already added here. Okay, you can do like that same. Okay, so this is an hard disease. This is a hard disease, no? Yeah. This is a 1025 data, so don't worry about it. Okay, X data, and I have used here random imbalance technique, that is a random oversampler. So this will give you a multiple outputs. And yesterday, day before yesterday, I have never explained you stratify k-fold. You have to pass the stratify k-fold class like that and create in KSF. This is my variable, and this same KSF I'm using for the this cross validation technique. Wait, see, this is my cross validation technique, and I have created that data. Where is that data? This X data and Y data. Who is that X data and Y data? That is an random oversampler after random oversampling, means after balancing data. Okay, and created the X test and X trend, Y trace, Y trace with these four variables that previously we have created. Now, what happens here? The score I'm going to calculate the cross validation score L1, X train and Y train we have passed. Which one? This one. This one. And prediction purpose, what we have trained, what we have passed, X test and Y test. Still, we haven't passed any kind of confusion matrix here, right? So that is also one thing that we can pass here, not an issue. But now I'm going to tell you this after execution, the how this part is changes here. With KSF, KSF. See, when I pass, see, this is your output, no, right? Check out one, and I haven't passed here. This is balancing, and if suppose graphical representation, if I created, definitely I will upload that in, so that you can do the yourself that model tuning. And even we are going to check this one. See, what I'm going to do here? I'll write down some terms so that it will be useful to you. check out, is there any notebook? Just write down the last one, write down the last one. Okay, the last observation values, this is 1, and write down it is, this is first loop, no? How many times this is executed? This is going to execute how many times? The 5 times. So you have to write down the 5 terms. So whenever I go there, this is 1. Okay, and write down accuracy score 81, 81.95. The first loop, this is 1, accuracy is 81.95, and confusion matrix you will get here. I have to take one cell here. Wait, I will go here into this one. The first loop. Okay. This is second loop. 0. Just write down there 0. Third one. See 0. This is 0. And fifth one is 1. Fifth one is 1. Now check out the sizes here. This is first one. The stratify makes the same proportion, means he is trying to balance the cross validation loops. 100, 105, 81 percentage. Second loop, that is giving the same proportion of data, 100 to 105, 87 percentage. But check out 81 percentage, 87 percentage, then definitely this will affect on the confusion matrix, right? Third one, check the data set balanced, 82%, and this confusion matrix, but here also balanced, fourth one also balanced and 80%, and check the balance. Third one, this is imbalance. Why? Because your count, means last count, if suppose you have an odd count, then definitely he will affect always. So but this is 99.9% balance, because check out the 100% and 105, right? And second one, 99, 106. So this is an 83%. So as comparatively, if you think about percentage of accuracy, check out what will happen. 81, 87, 82, 80, and 83. So maximum you go with this one, no? 87% of accuracy, right? 81, 87% of accuracy. Even if you pass the whole data set on this one, we have to check with the this accuracy is staying with the same or not, right? The first thing. Now the point is to be discussed, accuracy scores, sorry, confusion matrix, right? How this is try to reduce the values, because you can believe on this model, no? What I'm saying to you, you can believe on this model, because this model learns a lot of things. This model even learns balanced data, because here we have used which cross validation technique, stratify. Before the stratify you have used only k-fold. So in my opinion, if you are your means model is unbalanced, balanced data set is learning, then definitely you can believe on this. And always you always go with this one, means 87 percentage, right? Actually, the whole journey isn't completely based on the R&D. Model tuning means sizing and all. But with the cross validation and without cross validation, there isn't some difference of your output. So in my opinion, you should go with the both processes. What I'm telling you, both processes, and I will try to give you means that scenario how to tune the model, right? This is whole process. I'll copy this code, cut it down. See, in this example, in Friday's example, I have given the important questions on cross validation score, so you can go with it. Okay. And one more thing, last one more thing. What is the count that we got here? 1, 0. Same input you are passing, no, same observation. 1, 0, 0, 0, and this is 1. Who is winning here? Majority voting. How much zeros and how much ones are there? More zeros. 3, 2, 3. So 3 is a majority voting. So you know the cross validation definition. Majority voting always wins. Which class is getting more votes means more answers. So there that wins. So 5 times. I think. Hope you got this one. Name is confusion matrix. So confusing to be honest. Yes, actually, even sometimes if I'm telling to you, no, different questions are coming. Even I'm getting confused. Also, what type of, in which way I have to explain this? Because the terms are same terms and based, but definitely you have to go for this example. Now, KNN, yeah, you can use the KNN, but you know, while going through the KNN, there is an distance matrices, you know, the way I explained you. So you can change the different distance matrices. Maybe that affects on the output. Is it correct, Nishan? If you change distance matrix on the Euclidean distance and you know Manhattan, then definitely it will affect. Some points got it. No, actually, go through that once again. This video, this will helpful to you. Some will affect, some will helpful to you. But when we go for, you know, still we haven't covered that algorithms. That is a random forest. That time we are going to use this one, but you will help. You will get that one. We'll go through the again upload when finished. No, I will upload this file. Okay, this file and this file, both files, because this is an end-to-end work. No, now this examples are end-to-end. Are you getting my point? What I'm telling you. This is accuracy scores you are getting. Even votings also you got now. Is it correct? Means five questions you are 5 times you have asked one question to the model. 5 times you are asking and getting the majority voting. This is the end of one, but it's kind of trustful or not. This is the major issue. Means your output is trustful or not. So the study purpose, you have to do one thing. Actually, only 6 algorithms are there. 6 to 8 algorithms are there, and you know, study differently. Do not go with the group of means bunch of that one. If you want to go for the study, first learn about how to slice, how to balance. This is do the module wise study. If you want to study the about performance matrix, go with the only study of performance matrix. All the data science, I will tell you one thing. Python is most important. If your Python is good, then everything is good. First, basic, do the basics. Yes, Python. Second, some basic terms about the stats means variance means and mean means standard deviation means. These are the things. After that, directly you can enter into the pandas and numpy. Pandas and numpy, that is important. These are your whole journey of that pandas and numpy. In the pandas and numpy, do not go deeper there. Pandas, you have to learn about how to do a process of null values, working on the string, removing the garbage values, right? Label encoding, one hot encoding, these are the terms. After that, you should go with the machine learning. But before you going to the machine learning, you should go for the whole journey of how the step by step execution will goes there. Kindly upload outcomes this week session. Yes, sir. Thank you so much. Yeah, I will. Okay. In if you are going through the interviews with the machine learning, definitely you will get a question on the what is imbalancing, what is cross validation technique. You have to check that one. You have to take that challenge with it. Yeah, actually I have to show you, I have to tell you everything, the questions. I think I will create some list of questions. I will create. Already I have created near about 30 to 40 questions. I will create list and upload it. I think give me only 2 days. Tomorrow's and day after tomorrow's. Till the Wednesday, no. Before Wednesday, I will tell you. I will show you. Don't worry about it. I will pass. Can you please upload PPT based on algos? Algos, which algorithm is remaining? I think Kn in remaining till the last one, but I will pass that. Yeah, I will pass the list. Send to our personal email ID. Yeah, I will inform to our team. They will share it with you. I want to pass my interview. No, it definitely will pass the interview. Don't worry about me. Till I don't worry about me about your interview sessions. Whatever the questions I'm going to show you, that will definitely ask by the interview. Definitely. Yeah. Thank you so much for joining this session. Yes, hope you enjoyed. Thank you so much. And take care, you all. Thank you. See you on next week. Before that, enjoy. Thank you. Bye bye.